Bananas are harvested at a specific green maturity index, typically requiring a minimum of 21 days of green life before natural ripening begins. This climacteric fruit must be prevented from producing its own ethylene during the entire transit phase, which often exceeds 2 weeks. The primary logistical challenge is managing the fruit's respiration rate, which generates heat and accelerates senescence. If the cold chain fails, even briefly, the fruit can experience chilling injury or initiate an irreversible ripening cascade. The entire supply chain is engineered to maintain this state of suspended animation until the fruit reaches the final distribution center. This requires precise temperature management and chemical intervention from the moment of harvest. Immediately after harvesting the green hands, bananas are transported to packing stations where they undergo rigorous quality sorting based on length and caliper measurements. The cut surfaces are highly susceptible to crown rot and stem end rot, necessitating immediate post-harvest treatment. Hands are submerged in aqueous solutions containing approved fungicides, such as thiabendazole or imazole, to mitigate fungal pathogens during transit. This chemical barrier is essential because the high humidity and moderate temperatures inside refrigerated containers create an ideal environment for mold growth. Proper drying and ventilation post-treatment are crucial before the fruit is sealed into corrugated fiberboard boxes, ensuring the integrity of the protective chemical layer. Ocean transit relies heavily on controlled atmosphere or CA technology within specialized refrigerated containers. Standard refrigeration only controls temperature, but CA actively manages the gaseous environment to suppress respiration. Oxygen levels are reduced significantly, often maintained between 2 and 5%, while carbon dioxide levels are slightly elevated, typically between 3 and 6%. This hypoxic and hypercarbic environment slows the metabolic rate of the fruit, delaying the production of endogenous ethylene. Precise monitoring systems continuously sample the container atmosphere, adjusting nitrogen injection or ventilation to maintain these narrow parameters, thereby extending the green life of the bananas by several weeks. A key technological intervention used to guarantee green life is the application of 1-methylcyclopropene, commonly known as 1-MCP. This compound is a potent inhibitor of ethylene action. 1-MCP is applied as a gas within the container or storage facility, where it binds irreversibly to the ethylene receptors on the banana cells. By occupying these receptor sites, 1-MCP prevents the fruit's own naturally produced ethylene from initiating the ripening process. This molecular blockade provides a critical buffer against temperature fluctuations or minor logistical delays, ensuring the fruit remains unresponsive to ripening signals until the 1-MCP effect wears off or is overridden by forced ripening procedures at the destination. Upon arrival at the destination port, the integrity of the cold chain must be maintained during the transfer from ship to inland distribution centers. This transition phase is highly vulnerable to temperature abuse. Refrigerated containers are immediately plugged into shore power or transferred to refrigerated chassis units. Quality control inspectors perform pulp temperature checks and assess the fruit's physical condition, looking for signs of chilling injury or premature ripening. Any deviation from the mandated pulp temperature of 56 degrees Fahrenheit triggers immediate corrective action. Efficient port logistics minimize dwell time, ensuring the fruit moves quickly into temperature-controlled staging areas before being allocated to specific ripening facilities.
The final stage of control occurs in specialized, airtight ripening rooms. These rooms are equipped with sophisticated air circulation systems to ensure uniform gas distribution and temperature control. Ripening is initiated by introducing exogenous ethylene gas, typically at concentrations ranging from 100 to 150 parts per million for a 24-hour period. Ethylene is often generated on-site using catalytic generators that convert liquid ethanol into ethylene gas. This forced application overrides the residual effects of 1-MCP and triggers the fruit's natural ripening cascade, initiating the conversion of starch into soluble sugars and the development of color. Temperature management is the most critical factor during the ripening cycle, dictating both the speed and quality of the final product. The standard ripening temperature is maintained between 62 and 68 degrees Fahrenheit. Lower temperatures slow the process, but can result in dull color development, while higher temperatures accelerate ripening but often lead to soft texture before full color is achieved. Ripening room operators utilize differential temperature control, often starting slightly higher to initiate the process, then lowering the temperature to slow the starch-to-sugar conversion, ensuring the peel color develops uniformly alongside the pulp softening. Precise humidity control, typically 90 to 95%, prevents excessive moisture loss. The commercial banana industry uses a standardized 7-point color scale to manage inventory and retail delivery. Scale 1 is hard green, Scale 7 is fully yellow with brown spots. Most retailers demand delivery at color scale 4,
which is fully yellow with green tips, offering maximum shelf life for the consumer. Ripening schedules are meticulously planned based on retail order forecasts and required delivery dates. A ripening facility must manage multiple rooms simultaneously, each holding fruit at different color stages, ensuring a continuous supply flow. This inventory velocity management minimizes waste and maximizes the time the fruit spends on the retail display. The use of post-harvest treatments, including fungicides and ripening agents, is strictly regulated by bodies such as the Food and Drug Administration in the United States and the European Food Safety Authority. Maximum residue limits, or MRLs, are established for all chemical applications, and compliance is mandatory for market access. Ethylene gas is classified as a plant hormone and is generally recognized as safe, leaving no harmful residue. However, the application of 1-MCP must adhere to specific usage protocols to ensure worker safety and proper ventilation. Traceability systems are implemented throughout the supply chain, linking every box back to its origin farm and treatment batch for rapid recall capability. The next generation of banana logistics focuses on predictive analytics and non-destructive testing. Advanced sensor technology, including near-infrared spectroscopy, is being deployed to measure internal sugar and starch content without damaging the fruit. This allows for more accurate assessment of the fruit's physiological age, moving beyond simple visual color charts. Machine learning algorithms analyze transit data, temperature logs, and atmospheric conditions to predict the exact day a batch will reach a specific color scale. This predictive capability minimizes the risk of over-ripening and significantly reduces food waste, optimizing the efficiency of the entire global cold chain network.